Hey, today we are going to be on pages 7 and 8, and we are going to put this together and actually do a system of inequalities. So this is what we usually will see. We've kind of done all of our background stuff, and now we're ready to do a system. Remember that a system just means more than one. Okay, so when we did systems of equations, we saw where did the two lines intersect, and when were they the exact same. Okay, that was usually at one point. So now we're going to do inequalities. So inequalities have a bunch of points. So we'll kind of talk about what that means. So use the grids to create a graph for each linear inequality. Then we're going to answer some questions. So we have y is less than or equal to negative x plus 6. So we're going to start at 6. Then we're going to go down 1, right 1. Okay. It's less than or equal to, so it'll be a solid line. Okay. And then the shading would be anything y is less than or equal to. So we are shading below. Right. For the next one, we have y is greater than x minus 6. So we're going to start at negative 6 and go up 1, right 1. Okay, it is just greater than, it's not or equal to, so we have like a dashed line. Okay, and then for shading, I'm going to use a different color. We put our pencil on the y-intercept, and it is anything greater than this line. Shade above. Okay, so now it looks like we're ready to answer some questions. All right. List 3 ordered pairs that represent solutions on both inequalities. So we kind of see which would be solutions for both. Okay, so looks like 0, 0, my favorite point, is definitely 1. Okay, negative 1, 1 would be in both of them. And 2, negative 3, 2, negative 3, yep, those are on both of them. All right, then it asks, is 6, 0 a solution to both inequalities? So 6, 0, that works for this one because it's on a solid line. 6, 0, well, that's on a dashed line. So no, it wouldn't be because it's on a dashed line. Okay. If the inequalities were graphed on the same coordinate plane, how would you identify the solution set to both inequalities? So it's asking, where would it be? Like, how could you see the solution set for both of them? Well, it kind of looks like it would be shaded for both of them. Okay, so a system of inequalities is a set of 2 or more inequalities with the same variables. System talks about the same thing, so we have the same variables. The solution set to a system of inequalities includes the set of ordered pairs that makes all of the inequalities in the system true. So like up here where we had to come up with 3 ordered pairs, we had to come up with where they were shaded in both situations. When graphing a system of inequalities, the solution set is represented by the intersection or the overlap of the shaded regions. So where are they shaded in both graphs? Okay. So solve each system of inequalities by graphing, then state whether each ordered pair represents a solution to the system by writing yes or no. Okay, so I'm going to show you guys 2 different ways of doing this. You'll kind of probably like the second way eventually, but at the beginning you might like the first way just to kind of visualize what we're doing. Okay, so we have 2 equations, so we're just going to graph both of them. Y is less than 2x plus 2, and y is greater than or equal to negative x minus 3. Hey, Brogan, come here. Come here. Okay, so I'm going to start at 2. and my slope is 2, so I'm going to go up 2 over 1, up 2 over 1. I'm going to go backwards. Okay, this is going to be a dashed line. Okay, so what I'm going to do first is I'm just going to graph them separately like they were 2 different problems. So put my pencil on the y-intercept. Y is anything less than 2x plus 2, so everything below this line. So I'm just going to shade this entire section that I can. Okay. Now I have this second one. Y is greater than or equal to negative x minus 3. So I'm going to go start at negative 3. I'm going to go down 1, right 1, down 1, right 1. Okay. And again, I'm not looking to see if they cross exactly at one point because a solution to an inequality has multiple points. Okay, so this is going to be a solid line because it's or equal to, oopsie. Okay, and now I'm going to shade, and I'm going to shade a different color. I'm going to use just like a blue. Okay, put my pencil on the y-intercept, and y is anything greater than or equal to this point. So we have these two inequalities, and what I'm interested in is where they overlap, okay, or where they are shaded in both of these. So if I look right here, this is only blue, this is only green, this is neither. And this section right here, this region is both blue and green. So that section is actually our solution. So right here is our true solution to this system. Okay. So really, this is the only part that I actually care about. Okay, so that asks a couple questions, okay? Is 0, 0 a solution to both of them? So 0, 0 is right here, okay? And it is in that blue-green area because it's shaded in both of them. Yes, this is a solution to the system, to both of these inequalities, okay? Then we have 4, negative 3. Again, it's in that blue-green section. It's shaded in both of them, so yes. And then negative 2, positive 3. This is only in the blue section. It's not in the green section, so no, this is not a solution to both of them. Okay. Now I'm going to show you guys another way of doing this. We're just more of like a visual way, a quicker way. Instead of using 2 different colors, you could also do it this way. So again, I'm just going to graph it the way I know how to graph it. Y is less than or equal to 1/2 x. So I start at 0 and go up 1 over 2. And then I notice that is less than or equal to, so I'm going to do a solid line, okay? And so the way I'm gonna do this is I'm not actually going to shade quite yet, okay? It's important to know which direction I'm gonna shade. Y is less than or equal to, so I know I'm gonna shade down, okay? But I'm not actually gonna shade quite yet. I'm just gonna visualize it here in a minute. Then I have x plus y is less than negative 4. So I need to move this x over to make it graphable. Okay, so I move that x over with a negative x, and I'm going to start at negative 4. I'm going to go down 1, right 1. Okay, it is less than, but not equal to, so I need to have a dashed line, which is kind of hard on a computer. Okay, and then again, I'm just thinking about the shading. Y is less than this line, so I am going to shade down. So what I'm going to do is I'm just going to kind of visualize right now. Okay, so here's my first line. Y is anything below that, so I know it could be here or here. Okay, then I have my other one, this line. Y is less than this, so it could be this one or this one. Okay, so where they both are is right here. So my true solution, the only thing I really care about is right in this section. Okay. So to me, this just kind of looks a little bit easier for me, but you could definitely use two colors and kind of see where the colors overlap. Okay, then we have to figure out which ordered pairs are solutions and which are not. 0, -4. 0, -4 is on a dashed line, so that cannot be a solution. Okay, -3, -6 is definitely in the shaded solution. And then -5, 0 is in neither of them, so no. Okay. All right. Number 3, y is greater than or equal to -6. So -6, this is going to be a Hoy equation. Okay, could be a solid line, so I'm going to use a solid line. Okay. I do just kind of like to think about it. Y is going to be anything greater than -6, so it is going to be up. Okay, and then we have this second one. I need to move the x over. Then I need to divide by the 2. Because I'm dividing by 2, I don't need to flip the sign or anything, so I have -1/2 x plus 2. Okay. So I'm going to start at 2. I'm going to go down one, right 2, excuse me. Okay. This is going to be a dashed line because it's a less than. Okay. And then it is going to be anything below this. Okay. So I just kind of need to visualize this. So my first one right here is anything above. So it could be anything right here, right here, right here, right here. Okay. Just not below. Then we have anything for this red line, anything that is below. So it could be below, below. So my solution is anything below the red line, but above the purple line. Gosh. Stop. All right, last one. For these ones, y is greater than 2x plus 5. Start at 2, go up 2 over 1. Okay, is going to be a dashed line. Okay, then for the other one, we have to move the x over. So 4x minus 8, then divide by the 2. So 2x minus 4. Okay, so start at -4. Go up 2 over 1. Okay, this is a solid line. And again, we might think, oh my goodness, this is a no solution problem, but we have to think about the shading. Yes, these lines are never going to cross, but solutions for inequalities is the shaded region. So we have to be very careful about what the shade is. Just because they don't cross, it really matters about inequality, the inequality of it and the solution and the possible solutions. Okay, so for this first one, y is anything above 2x plus 5. So it's everything above. So I'm just going to kind of draw some up over there. Okay. And then for this other one, y is anything below the green line. Okay. So there's never a time where both of these are shaded. So this actually is no solution. Whoa. Okay. Toby believes that if the lines in a system of inequalities are parallel, they're always going to have no solution. Do you agree or disagree? Well, I actually disagree, because if I were to write the same exact problem, but instead of it being y is greater than 2x plus 5 and it was y is less than 2x plus 5, so we just think about that for a second, 2x plus 5, that would mean that our red line, Oopsie. Our red line would be shaded below. So then it would have solutions. Okay, so I disagree because it matters about the symbols of the inequalities. Symbol of the inequality and the overall shading. Broke it. Stop. Sorry, my dog's crazy. So number 6, use the system of inequalities shown to answer C. So we have this picture, it's already graphed for us. Write a system of inequalities represented. So we look and we see we have a really the dark shaded region. So that is our actual solution. So we need to keep that in mind. So we'll do this one first. Stop. Okay, so we have a horizontal line, so it's going to be a Hoy equation. So it'll be y, and the y-intercept is 6. Okay, it's a solid line, and it's shaded below because that's where the darker region is. So it's shaded below. Y is less than or equal to 6. Okay, then we have this dashed line. Okay, the y-intercept is 0. The slope is right here, so we needed to go up 6 over 4. So simplify, that'd be 3, 2. And it starts at 0, so we don't have to put anything. Okay, it's a dashed line, so I don't need to have an or equal to. It's just going to be greater than or less than. And I think about the shading, it's above this line, so it's going to be greater than 3x. 3 halves x. Okay. Then it says, what are 3 ordered pairs that are in the solution? You could put any 3 that are in the shaded region. -6, 6. -6, 2. -8, 4. All of those are in both shaded regions. Okay. 3 that are not in the shaded region. 0, 0 technically is not because it's on that dashed line. 8, 0. 10, -4. Okay. Last problem. Jessica bought hot dog buns and hamburger buns for a neighborhood cookout. The total number of hot dog buns and hamburger buns was less than 50, and Jessica bought more hot dog buns and hamburger buns. If X represents hamburger buns and Y represents hot dog buns, the situation can be represented by the system below. So we have hamburger plus hot dog is less than 50 things, and that she bought more hot dogs than hamburgers. Okay, so it asks us to graph this inequality. So first I'm going to move this over. So y is less than -x plus 50. So I'm going to start at 50. I'm going to go down 1, right 1. These are at a scale of 10, so it's okay to go down 10, right 10. That's equivalent to -1. I'm going to use a dashed line. And I'm going to wait to shade this. Okay. Then our other one, y is greater than x. So we're going to start with nothing. And we need to go up 1, right 1, or up 10, right 10. That's equivalent to, hey, no. That's equivalent to 1. Again, I'm going to use a dashed line. Okay, now we have to think about the solutions. For this one, it has to be below the pink line, but it also has to be above the green line. So that shading would be right here. Well, technically it would be all the way right here. List a possible combination of hot dog buns and hamburger buns that Jessica could have purchased. So I'm just going to use that one, you know, I don't care. X is 10, Y is 20. So 10 hamburger, 20 hot dog. Okay. Finally, it says, are there any ordered pairs in the solution that do not make sense? And that's kind of why I hesitated, because it doesn't make any sense to even have this part of the graph, okay? It doesn't make any sense to have negative hot dog buns and negative hamburger buns. So if I were to redo this, I wouldn't even have the negative concept on this coordinate plane. I would have the positive. I would have the first quadrant, because that to me makes the most sense. Because again, we can't have any negative hamburger or hot dog buns, because that makes just no sense. So any negative numbers, because we can't have negative buns, whether they be hot dog buns, hamburger buns, it doesn't make sense either way. All right, for today, there's going to be some Delta math practice.